Hello everyone. Today I will be discussing about another statistical technique which is called as analysis of variance. So basically analysis of variance is used whenever you are trying to compare more than two groups. Suppose you are trying to compare different boards of education in terms of different boards like CBSE, BSCB or ICSE or Jharkhand board or Bihar board. So if you are comparing more than two groups in terms of certain dependent variable, suppose the categorical variables are more than two, in that cases you are using analysis of variance. Of course you can always use ANOVA by calculate ANOVA using SPSS, but I will be discussing here how to calculate it manually. How calculation is done manually, that we will be discussing. So analysis of variance was developed by R.A. Fisher in the year 1920. If the number of sample is more than 2, then the t-test cannot be used. That you already know that t-test is used whenever groups are 2 in number. Different types of t-tests are there. But if it is more than 2 groups, then you are using analysis of variance method. So ANOVA is a popular statistical method that determines the relationship between two or more groups in statistics through the analysis of variance. Although you can do it for 2 groups also, but always t-test is better than performing ANOVA. But it is widely used whenever the group's number is more than 2. So to see the difference between more than 2 groups, the analysis of variance is used. Formula to determine the number of pairs, how many different types of comparison it will do whenever you are doing after ANOVA. Suppose 3 boards are there, so it will how many comparison it will make, how many types of differences it will try to study. So that number of pairs you will calculate using this formula, n into n minus 1 by 2. So suppose 3 boards are there, so 3 multiplied by 3 minus 1, 2, 3 minus 2 is 3 minus 1 is 2, so 3 2 is 6 divided by 2, that is 3. So 3 comparison it will make. Suppose 3 boards are there, Bihar board, CBSE board and ICSE board. So once you will compare ICSE, Bihar, CBSE, ICSE, like this, 3 comparison will be made. So in that way you can understand. So let us try to see the basic assumptions before you are going to perform ANOVA. The essence of ANOVA is that the total amount of variance in a set of data is divided into 2 types: the amount that can be attributed to chance and the amount that can be attributed to specific causes. Variance analysis methods should be used where the significance of difference between means or values between more than 2 groups needs to be tested. So already I told you, if more than 2 groups has to be tested, then you are using analysis of variance. The transmission analysis method should be used to differentiate between subgroups of individuals that are sampled from a normally distributed. So normal distribution is a must whenever you are performing ANOVA. So whatever set of variables that you want to compare, suppose achievement test score, suppose interest score, that should be normally distributed. This analytical technique should be used where the variance of different subgroup is homogeneous. So if more than 2 groups is there, the homogeneous variance should be there, similar type of variance should be there. The parameters selected must be independent. Then variance analysis should not be used to determine the significance of difference between groups or means. So the observation should be independent from each other. That criteria also has to be fulfilled. So you have seen the meaning of analysis of variance. Whenever there is more than 2 groups, then you are going to use analysis of variance. The variance of number distribution is the sum of the squares of the deviation from its means, and the standard deviation is the square root of such square deviation. So standard deviation you already know that basically we are using the variance method. Standard deviation and variance is used whenever you are calculating analysis of variance. Now there is basically, I will be explaining you one way ANOVA, but there may be more than one way of ANOVA. 2-way ANOVA is there, 3-way ANOVA is there. So what are that? I will not explain that one with example, but let me give you the idea about what is 2-way ANOVA, what is 3-way ANOVA. So suppose I told that if you want to see the difference between different boards of education, so this is 1-way ANOVA. Only one particular categorical variable boards you are using here. But if it is more than one, suppose we want to see the difference existing due to board of education and also due to the medium of instruction. So if you want to combine these two things and you want to see the achievement of the student based on the medium of education and based on the board of education, then it becomes two-way ANOVA. Similarly, if you want to see the uh, board of education and the gender, if together they are having any effect, then it is also more than one way ANOVA. So that way also, that is also called as factorial design. So that factorial designs is you can use. So there may be two-way ANOVA, three-way ANOVA, four-way ANOVA, but basically many a times you are using one-way ANOVA, that is maximum times we are using. I will be explaining with example one-way ANOVA. So let us try to see. So let us take one example how to perform one-way ANOVA. So just try to see, here is one example. The aim of an experimental study was to determine the effect of three different techniques of training on the learning of a particular skill. So three different techniques were used, so three different groups are there, and then you are trying to see the achievement of the student in terms of their skill. Three groups, each consisting of 7 students of class 9th assigned randomly, were given training through these different techniques. The score obtained on a performance test were recorded as follows. So scores are there, you can see the scores of the first group, the score of the second group, and the score of the third group. So it has been here. How many participants are there in each group? 1, 2, 3, 4, 5, 6, 7. 7 participants are there. So, and they have been trained with different training techniques. So after that, what you have to do, you have to just try to see what the table is explaining here. So you can see here the table is, you can see this table, so this is the group 1 scores, this is group 2 score, this is group 3 score, and then the total value is there. Total value also has been calculated, adding these three terms. So, and in the different column also you have got summation of x1, summation of x2, summation of x3, and then total sum of each sum is also there. And then you square each of the group variables. For group 1, x1 square, x2 square, like this we have squared. And similarly for the second group, for the third group, x1, x2, x3, for three different groups you square each of the term. So you have got x1 square, x2 square, and then x3 square, and you add these three also. So this is the sum you got, and so this is the sum of all the x squares what we have done, that sum is there. So what you did here, you just squared each, you just added all the terms. So you got sum x1, then sum x2, sum x3. You can take it x, y, z also, but I am taking it in terms of x because same achievement test is there for three different groups. So x1 sum, x2 sum, x3 sum you got, it will be x3 here, x3 sum you got, and then the totals of sum is also written here. Similarly, now square these terms in all the groups, and then again totals sum of. Now to see the steps, you have already seen the table. What we have done, you have got the different sums of x, sums of y, x2, sums of x3, and then you have also got the sum of squares also. Now the first step is to get the correction terms. So you have seen the different sums. You have seen I have calculated sum of x, sum of x1, sum of x2, sum of x3. So total sums are there, and then square sum is also calculated. Now in the first step you have to calculate the correction term. So correction term formula is all this summation of x, whatever sum you have got, square that one divided by total number of n. Total number of n is 7 into 3 group is, that is 21. So and sum of x is 96. All the x if you add, just you add 3 plus 5 plus 3 plus 1, this all you add, this all these three columns you add, either you add that one or you add 28 plus 35 plus 33, you will get 96. So this 96 is there in that formula. Square that term, 96 into 96 divided by 21, you will get the correction terms, and the correction term is 438.85. so this one is the first step. Now we just also see, you know that all n is equal to 7, total n is 21, and then means are also, you can see mean of x1 is 28 by 7, 4, mean of x2 is 5, and mean of x3 is 4.71. So first step, you calculate the correction term. Using correction term, you can calculate ANOVA easily. You can go directly, but then using this all means, if you go and perform ANOVA using this means, then it will be little difficult and complex calculation. That's why you are using the correction terms. Just like when you are calculating standard deviation, whenever you are doing different variance analysis or standard deviation, there is also the assume mean method is there, so that to make the calculation simplified. So similarly here also, using this correction term, you can simplify the calculation. That's why correction terms has to be calculated first. Then in step 2, you have to calculate total sum of square. So total sum of square is, this is the exact formula, sum of x square minus this correction term. This is the correction term that you have already calculated. So sum of x square means all the x square, all the term of x, x1, x2, x3, each and every term, you square it, then you add it, and then whatever sum you will get, subtract the correction term, then you will get the sum of square total. Let us see the table, you will be able to understand from there. So just try to see this, square this one, square this term, that is 3 square is 9, 5 square is 25, 3 square is 9, 1 square is 1. So in this way, 7 square is 49, 3 square is 9, like this. These all square terms are there. Similarly for the second column, square terms are there. So you add all these. So if you add all these, you will get the sum of x, or taking all x squares, all the terms square, if you sum, then you will get this value 518, which is written here. So this 518 minus the correction term which you have calculated just now, it will give you sum of square total. Sum of square total is sum of x squares minus correction term, so 79. So in step 2, you have calculated sum of square total. Now in step 3, you will calculate the between group sum of square. It is also called among group sum of square also. So in the each and every group, you will get this summation of x1 square divided by n1, summation of x2 square divided by n2, x3 square. So sum of x1, we already have seen it was 28. So 28 into 28 divided by 7. This is small n. Similarly here it was bigger n was there, total n was there, but here the sum of each group square divided by that number of sample in that particular. Similarly 35 into 35 divided by 7, 33 into 33 divided by 7, and then you subtract the correction term. This correction term you have calculated, so you have got the value as 3.72. So this is the formula for between or among groups sum of square. Now simply what you will do within group sum of square is sum of square total minus between sum of square. This, if you use these two, then you can calculate the within or the residual sum of square that you can get. So this is obtained as sum of square total minus sum of square between. So 79.15 minus 3.72. So you got, this is the sum of square within. Sum of square within this one. Now you have got all the values which you require to construct the F table to calculate ANOVA. You have got total sum of square, between sum of square, within sum of square. So now this is the table for calculating ANOVA. The ANOVA has been calculated here. Value is 0.444. Now two more things has to be learned, that is, one is between group sum of square and other is within group sum of square. Between group sum of square is because it is comparing between two or more groups, so it is k minus 1, where k is number of groups minus 1, that is here 3 groups are there, 3 minus 1 is 2, and sum of a square within is n minus k. N is the total number of n, total number of sample comprising of all the groups taken together, and k is number of groups. So here is n is 21 minus 3, that is 18 will be the within groups sum of degrees of freedom. These 2 degrees of freedom will be used to see the ANOVA table, because in ANOVA table 2 degrees of freedom are there, one is between groups and other is within groups. When you calculate F ratio, this is the table: among group variance, within group variance, sum of square between is 3.72, we have calculated, sum of square within is 75.43. Degrees of freedom, just now we have calculated how to calculate, and then total sum of square is also there, so you can get. And then you got mean square variance. Mean square variance is sum square between divided by df of this particular among group. Among and between is same. Sometimes it is saying sum of square between, sum of square among, both are same. And sum of square within group is mean sum of square within group is sum of square within divided by degrees of freedom, so it is 4.19. Then F value is sum of square between divided by sum of square within. So if you divide this 1.86 divided by 4.19, we will get the value as 0.444. So this is how we calculate F. So this is the formula which I was talking about: mean square variance between groups divided by mean square variance within groups. So you got the value 0.444. Now the critical value is for F 2,18 are the degrees of freedom, and this is for between and this is for within degrees of freedom, is 19.43 at 0.05 level and 99.44 at 0.01 level. Both the values are quite higher than the calculated value, so the null hypothesis will be accepted, because our computed value is not significant at both the level of significance. Hence the null hypothesis cannot be rejected, you have to accept that one. So in this way you calculate F values. So this was how to perform ANOVA analysis manually. There are 5-6 steps. You have to first calculate correction term, then you go for sum of square total, then you calculate sum of square among groups, and afterwards you can calculate sum of square within group, and then you construct the table, find out the degrees of freedom, construct the table, find out the mean sum of squares, and then you get the F ratio. What are the advantages? So you can compare multiple groups here, which is in t-test, which is not possible. Reduce risk of type 1 error by comparing all groups at once. ANOVA reduces the risk of making false positive because it compares all the groups together. But if you are comparing two groups at a time, then you can make it false positive. You can say differences are there, but because you are comparing all the groups together, so if you conclude something, that will reduce the chances of false positive, chances of type 1 error. So test of interaction. ANOVA can be used to test for interaction whenever you are using 2-way ANOVA, 3-way ANOVA. So interactions also you can see combinedly, you can see effect of board and medium of instruction, what is the impact. So in that cases also it has got advantage. ANOVA is relatively robust to violation of some of its assumptions, particularly when sample size are equal. So you can use it whenever sample size are equal or not equal. So it is one of the robust technique, means it is one of the advanced techniques which can be used for calculating for studying the differences in more than two groups. ANOVA can be used with various types of data and experimental design, including 1-way, 2-way, and factorial ANOVAs, which I already told. So this way ANOVA is useful. Now, what are the limitations of ANOVA? ANOVA relies on specific assumptions such as normality of data, homogeneity of variance, and independence of all the data values observation, which may not always be met in real world data. That is quite obvious. Many times conditions of normality are not met, then you cannot use ANOVA. ANOVA requires a sufficient sample size to ensure that validity, or always it is there that if sample size is large, then it is quite parametric condition, normality conditions can be met. So if sample size is small, then it is quite difficult to use ANOVA because assumptions cannot be made at that time. So that is also limitation. So ANOVA provides a statistical framework to compare the means of multiple groups and determine if the differences are statistically significant. It generalizes the t-test to more than two groups by partitioning the total variation into components associated with different sources. ANOVA has many advantages but also have some limitations. With appropriate application and follow-up analysis, you can go for post hoc test, which you can do using SPSS, so that you can see the actual difference where it is occurring. It remains a useful and commonly used technique for investigating different population. If it is more than two groups, basically 3 or 4, like this type of situation is there, you are using ANOVA, so it is quite useful. So I hope you can understand how to calculate ANOVA using mathematical steps. And if you have liked this particular video, kindly subscribe to the channel. Thank you. Keep learning, keep growing. Thank you.